Hi, Trig. Welcome to chapter 2. First, we're just going to review here's our angle in standard position, okay, initial side, terminal side. And we're looking at angle A, okay? The sign of angle A, we used to know as opposite over hypotenuse. Now we know it as the y-coordinate over r. Cosine of A, we used to think of it as adjacent over hypotenuse. Now we think of it as the x-coordinate over r. And the tangent of A, instead of opposite of it over adjacent, we think of it as the y-coordinate over the x-coordinate, okay, of any point that the terminal side goes through. Cosecant, of course, we just flip sign. So instead of y over r, it's r over y. Secant, we flip cosine, and cotangent is the reciprocal of tangent. Okay, so there they are, right triangle based. I kind of started trig this way. They remind you of it here again in chapter 2. So thinking of that, let's look at this right triangle where we have, this is angle theta and this is angle alpha. Okay, we want the exact trig values. When they say exact, they don't want you just plugging it in your calculator and getting some decimal approximation, okay? Instead, they want you to find the exact value. For example, if I want the exact value of pi, I say pi. If I want to approximate it, I say 3.14. Exact value for the sine of theta is opposite over hypotenuse, so that's not bad. Sine of theta is 24 over 25. Cosine of theta is 7 over 25. And the tangent of theta, opposite over adjacent, 24 over 7. If I go to my alpha angle, okay, then my orientation is a little different. According to, if in reference to alpha, the opposite side is 7. So the sine of alpha is 7 over 25. The cosine of alpha, when I'm talking about this angle, the adjacent side is 24. So that's 24 over 25. And the tangent of alpha is opposite over adjacent. So that would be 7 over 24. So what do you notice? What do we see about the sine of theta and the cosine of alpha? They were both 24 25ths, right? The cosine of theta and the sine of alpha are both 7 25ths. Okay? What happens is, you know, these angles are going to add to 90, right? Because the angles in a triangle add to 180, and we already have 90 taken by the right angle. So these add to 90. And then, so therefore, what we say about sine and cosine is that they're called co-functions. They're co-functions because the sine of one of the angles will equal the cosine of 90 minus the other angle. Any acute angle, the cofunction values of complementary angles are equal. So the sine of A is the same as the cosine of 90 minus A. We saw why on the other page. The cosine is the same as the sine of 90 minus A. Sine and cosine are cofunctions. One that we didn't notice were secant and cosecant, but doesn't that make sense? Since secant and cosecant are reciprocals of sine and cosine, secant and cosecant are cofunctions as well. And then we didn't really see this on the other side, but tangent and cotangent are also cofunctions. All right, so if we're asked to write cosine of 52 in terms of its cofunction, I know that the cosine of 52 is the same as the sine of 90 minus 52 is what, okay, if I want to think of it that way, okay? So the cosine of 52 ends up equaling the sine of 38. Okay, does that make sense? I hope so. Okay. Tangent. Well, tangent and cotangent are cofunctions. So the tangent of 71 is the same as the cotangent of 90 minus 71. So the tangent of 71 would be the same as the cotangent of 19 degrees. And the secant of 24, we can just, we kind of know there are complementary angles now. So we're thinking, okay, 24 plus 66 is 90. So the secant of 24 degrees is the same as the cosecant of 66. Okay, so sometimes we add a little algebra to the trig, right? These are cofunctions. You have to recognize these as cofunctions. What that means then is that whatever alpha is and whatever alpha plus 50 is, those two have to add up to 90, right? Secant of 24 equals cosecant of 66 because 24 plus 66 equals 90. So whatever I'm taking the cosecant of plus whatever I'm taking the secant of better add up to 90. 2 theta plus 50 equals 90. Subtract 50 from each side. 2 theta equals 40, so theta equals 20 degrees. And that makes sense, right? Cosecant of 20 should equal the secant of 20 plus 50 would be 70. Okay? Not bad. All right, look at these triangles. Let's say that R is a fixed length. Okay, whatever this length is the same. What we do is we open up the angle. The angle A increases. As angle A increases and R stays the same, look what's happening to X and Y. Y is getting bigger, right? As A gets bigger. But X is getting smaller. So let's think about how that would affect the sine and the cosine and the tangent. Okay? Which, sine has to do with opposite, the y value. So as the angle gets bigger, sine gets bigger, right? Increases. Sorry. Hopefully you can read my writing. Cosine, well, cosine has to do with x. So if x is getting smaller, then the cosine of A is getting smaller. That decreases. Tangent, similarly, will increase as sine does because y is getting bigger, x is getting smaller. It's y over x. That's getting bigger. Okay, bigger faster, huh? Okay, just something to think about. Let's take an equilateral triangle. Let's just say the sides are 2, 2, and 2. All the angles are 60, obviously, okay? If we cut that in half, okay, if we drop a 90-degree angle, we drop a perpendicular down here, we're going to have a 90, 30, 60 triangle, okay? This side will be half as much. It'll be 1. And the hypotenuse will stay the same as 2. So from there, we can find the sine and the cosine of these angles. The sine of 60 is x over 2. I have to find x, don't I? Oh, well, that's okay, because I can use the Pythagorean theorem. I know that 1 squared plus x squared has to equal 2 squared. So x squared is going to be 4 minus 1, or 3. It looks like x is the square root of 3. Okay, so the sine of 60 is opposite over hypotenuse. That's the square root of 3 over 2. The cosine of 60 is adjacent over hypotenuse. That's a half. Well, from what I just learned of cofunctions, I can tell you right now that the what the cosine of 30 is going to be, right? Okay, so the cosine of 30 has to be the same as the sine of 60. Let's see if it is. Cosine of 30 is adjacent over hypotenuse. Yeah, we knew it was. And the sine of 30 has to be the same as the cosine of 60, since 60 plus 30 add up to 90. They're co-functions, all that. Sine of 30 is opposite over hypotenuse, or 1/2. Okay, let's do that same type thing with a 45, 45, 90. In a 45, 45, 90, the sides opposite these equal angles are the same. R would be, let's see, 1 squared plus 1 squared would equal R squared. So 2 equals R squared. So R is the square root of 2. So the trig functions of 45, well, the sine of 45 degrees is opposite over hypotenuse. That's 1 over the square root of 2, or square root of 2 over 2 if you rationalize the denominator. The cosine of 45 degrees is adjacent over hypotenuse. So that's also 1 over the square root of 2. Oh, 45 degrees, we have the exact same sine and cosine. Makes sense. 45 plus 45 is 90. They're co-functions. Tangent of 45 degrees, that's opposite over adjacent. Oh, 1 over 1. That's one of my favorites. Tangent of 45 degrees just equals 1. And then, of course, we can flip those, find the reciprocals. Cotangent of 45 is 1. Secant of 45 is the square root of 2, and so is cosecant. Okay, so we have these special angles, we call them 30 degrees, 45 degrees, and 60 degrees. And this is another thing that would be handy if you would memorize. All right, we'll work on ways to memorize it during class, don't worry. And the more you work with it, you just start memorizing them anyway. I understand you can put them in your calculator, but the cosine of theta, if you put the cosine of 30 degrees in your calculator, then you're going to get a decimal approximation, and we're going to want square root of 3 over 2. We don't want that decimal approximation, okay? We just saw all these. Tangent was, oh, we didn't do that one, but it's square root of 3 over 3. Cotangent, we flip that, and we get square root of 3. Secant, I flip cosine 2 over the square root of 3, but then we rationalize it. Cosecant is 2 because I flip sine. The sine of 45 we saw was the same as the cosine of 45. Tangent we saw was 1. So, of course, cotangent is also 1. Secant, I flip this, 2 over the square root of 2, which ends up being the square root of 2, the same as cosecant. 60 degrees, well, we can just flip-flop these, right? Square root of 3 over 2, 1/2, square root of 3, okay? Same as the cotangent of 30, right? Square root of 3 over 3, and then 2 and 2 square root of 3 over 3, again, flipped. These are things that eventually we should have memorized, and I believe you will have it memorized by the end of this. Okay, those of you who had honors pre-calc or are going to take honors pre-calc, you know that you're probably memorizing it as well. Okay, here's your homework. Page 53, you all have your books now? Yes. I don't have to run off all that stuff anymore. 1 to 6, I'd like you to try all those, 8 and 10, and then every other even. Well, 12, 16, and then every other even. So 22, skip 24, 26, skip 28, 30, skip 32, 34. You know how to do every other even probably. And then these 3. Okay? I will see you for 2-2. That was 2-1. Yes, I will see you for 2-2. All right, see you in class.